Let's take a look at problem number 8. It says factor the sum or difference of two cubes, and this says this factor. Now, if it didn't say that, if we went through our different methods, our first method is GCF, which doesn't fit here. Next one is grouping, 4 or more terms. Well, this is not 4 or more terms. Next one is PSD, and that's when it's in the form x squared plus bx plus c, 3 terms, which doesn't fit. Key number, which is in the form of ax squared plus bx plus c, 3 terms, doesn't fit. Difference 2 squares, 2 terms of minus tringent, nope. Difference 2 cubes, 2 terms of minus tringent, nope. Sum of 2 cubes, 2 terms of the plus between it. That's the only one to actually try. So let's take a look at it. Learn to speak one of these days. Okay, so we got n to the third plus 125. Now this is the sum of 2 cubes. With the sum of 2 cubes, we try to rewrite this as something to the third power plus something else to the third power. And you ask yourself, what times itself 3 times gives you this particular item? Like the n to the third. N times n gives us n to the third. And 125, 5 times 5 is 25, times another 5 is 125. Now, I'm going to label what's inside the first set of parentheses as F for first. Now, I'll label what's in the last set of parentheses as L for last. Now, the formula for the sum of 2 cubes is F plus L times F squared minus FL plus L squared. Now, wherever we have an F, we'll plug in n. Wherever we have an L, we'll plug in 5. So I got n plus 5, then n squared minus n times 5 plus 5 squared. Well, n squared, then minus n times 5 is 5n, and 5 squared gives us 25. This always looks like you can do more with it, but this would have to be a negative 10 in the middle for you to factor it further. N plus 5, n squared minus 5n plus 25, D as in David, would be our answer.